First of all, in an endeavor like this, there are a lot of people to thank. The people that have done a lot of the work on the research that I've continued at Scottsbluff are listed here: Rex Nielsen, Jim Markheim, Allison Hazen, and Gary Stone. I came to North Platte in 1975. We celebrated the centennial in 2004. The North Platte Experiment Station was put where it is because, if you remember back in your history of the Great Plains, what's that magical line that runs through Cozad? The 100th meridian. Way back when, what was west of the 100th meridian? The Great American Desert. So that was kind of a magical line back in the early part of development of this country, and they didn't really think agriculture was feasible west of there. So when the university started, they decided they would put an experiment station a little farther west than the 100th meridian to see how practical dryland agriculture and agricultural in general was. And that's why the North Platte Experiment Station, West Central, was started. This quote from Thornthwaite from the 1945 Book of Agriculture kind of says it: "We do live in a variable climate that is dry." Gary Stone's an excellent photographer. These are just some shots from up in Sheridan County from this summer. There's not much growing. A few years ago, we went through depending upon which part of the state you're in, a 8 to 9 year drought. These are just some pictures in Nebraska. And the thing that after a couple of good wet years, we had another dry one. Are we at the repeat of another one of the dry cycles, and are we going to see some of these things repeated? Darrell already showed you this one. You know, we've got major areas of decline, but what nobody talks about a lot is we have areas in the state where we have major increases in groundwater, and there are reasons for that. The one here I call the Great Displacement of Lake McConaughey. That's the Tri-County that we've been irrigating and adding to the groundwater for years, and the groundwater level has increased 70 to 80 feet in some places. This is from a result of the reservoirs up in the Central 4 area. And talked to Jim Gakey the other day, and I thought that this increase here in Lincoln County was due to the leakiness of Sutherland Reservoir. He said that's really not the case. He said there's just somewhat of a retardation of the groundwater flow toward the river here, and that's part of what's causing that increase. So that was kind of interesting. And as Darrell mentioned, what all of the declines have led to is groundwater and surface water moratoriums. He's also seen this. So just like with any class, you're going to see some repetition, limited deficit irrigation. If you've got a center pivot, you can do this very easily. If you are furrow irrigated, you can still do it, but it's a little more difficult. It's easier to do in a ridge till type situation. Wider rows work better because you're not dealing with the residue problem. Surge irrigation is also a plus. So a lot of what we're going to talk about today probably fits with center pivots, but it can be adapted to furrow irrigation systems. The thing is, when you start really talking about truly deficit irrigation, you have to think like a dryland farmer. And that's hard to do as an irrigated farmer, okay? And you need to be very aware of your beginning soil water content. Because if you think in a dryland context, you need to have enough moisture to get the crop up and going until you can put on that limited amount of water during the critical reproductive period. And we'll cover that somewhat. So what I'm going to talk about today is some research on a crop rotation that I've been doing for about 8 years at Scottsbluff. The rotation is winter wheat, followed by corn, followed by dry beans, followed by spring canola. And on the wheat, beans, and canola, I approach this from the standpoint of like an allocation. 4, 8, and 12 inches. The wheat that gets 4 inches, the next year goes into beans that gets 4 inches, which is followed by corn that gets 4 inches, followed by beans. So 4 inches is always low. Because corn has a little higher water use, the levels are 5, 10, and 15. Now generally that highest water level is what we approximate as a non-ET limiting water amount. If we need more, we will put it on. There's only one time when I've had to do that on the corn, and I've never had to do it on the wheat, beans, or the canola. All of this started about 30 years ago, and I think this is the 30th anniversary of when Clucky and I started the limited irrigation research plots at North Platte. This whole idea grew out of what I had learned by working with Gail Wicks on EcoFallow when I got here in 1975, and also the work that Darrell Watts was doing, and he had this young grad student called Darrell Martin when we worked up at the Sandhills Ag Lab back in the mid-70s, and we were doing things called stress conditioning and working with line source sprinklers. Essentially what we learned is we got to think like a no-tiller dry lander to store the moisture to make the most effective use of the precip that we get, use the crop residue to suppress ET, and that ET suppression primarily comes when we irrigate and wet that surface. Timely application of the water. So again, a repeat of what Darrell's shown. We're essentially using concepts from no-till moisture storage. We're going to stress a crop during the vegetative period if we've got really limited water. If we are looking at water allocations, we have to realize that peak water use for different crops are going to be different. So again, with very different water allocations or low water allocations, this is part of the mix. And these are some of the things that you can play with in Water Optimizer. And then again, the idea that yield versus irrigation is a curvilinear function, whereas yield ET is a straight line function. I'm working on a sandy soil. I had a beautiful Kozad silt loam at North Platte when we did our research there. 2 inches or more of water per foot. I'm now working on a trip fine sandy loam that has about 6 to 7 inches of total water holding capacity in the root zone. We're at almost 4,000 feet, 15.5 inches annual precip, and a shorter growing season than North Platte by about at least 10 days. If we look at the panhandle in general, we probably still have 50% of what I would call conventional. There's still a lot of plowing, there's a lot of disking. We've seen a dramatic increase in strip till, and we still under irrigation probably have less than 10% what I call true no-till. We're probably now, with all the conversions that have gone on the last few years, 50% surface irrigated and 50% sprinkler. That sprinkler irrigation is a mixture of water sources from groundwater and surface water. So we have a lot of people who are building small catchment ponds, running surface water in and pumping it through a pivot. This is small plot research. Our plot's 40 by 70 feet. We're using no-till, sprinkler irrigation. Everything that I had done at North Platte, I could transfer to Scotts Bluff except our strategy on irrigating dry beans. And I had a little bit of learning to do there. You can't treat them like corn and wheat where you put the water on right at reproductive. You're better off, to make a long story short, to put it on kind of evenly divided over the growing season, because if you don't irrigate beans, they shut down. You start irrigating them, they bloom late, and then usually frost catches them. Precip, averages are dangerous. This is the 30-year average precip at Scotts Bluff. It's 15.6 inches, but you can see it goes from a low of about 6 inches to a high of almost 24.5. During the course of this experiment, this has been our rainfall. There's a 30-year average. Our 8-year average is 14, but it's ranged from a low of 6.7 this year. We're even lower than 2007, up to a little less than 20 inches. I'm only going to talk about the corn today, but just to give you some idea of what we're doing. The corn that we plant into wheat stubble is just like EcoFallow corn. We spray the wheat stubble with atrazine in the fall. We're using dual 2,4-D Roundup as needed. I modified my plant populations when I started this. We did 16, 24, and 32,000 for the 5, 10, and 15-inch irrigation. Planted both Pioneer and DeKalb varieties. We're generally planting 92 to 95 relative crop relative maturity dates. Row applied fertilizer. We generally apply our nitrogen on the basis of soil test and a guesstimate of what we think our yield projection will be. So these do get treated differentially, but they're never shorted on fertilizer, but it does vary based on the yield potential. One thing I'd like to mention is that, when you really get into deficit irrigation, and that's when you have 50 to 80% of full ET, you really have to modify your normal irrigation practice based on weather station and ET values. One of the questions is, how do you apply that limited water to get the most effect? And how will your strategy vary based on the crops that you select and your water source? Because if you have a pivot that you can go out and turn on any time, you have great flexibility. If you're using surface water that you're running through a pivot, you're limited by when your ditch company decides you're going to get the water. Once you see this, if you're on one of those ditch boards, you may want to go back and have a discussion of how do we allocate surface water for a deficit irrigation system. Should we keep doing it like Grandpa did it, or is there maybe a better way that we need to look at it, to look at delivering that water? So what I do is I start out with a spreadsheet. I look at full ET values, but when you have really limited water, and we look at phenology over here, on 5 inches, you see there's lots of zeros there. This is a dry year. I ended up putting on ½ an inch at the 4-leaf stage. I try to save it for around tasseling. The more water you have, you can spread it out. There's a lot of numbers to read, and I don't expect you to do that. Visually, the way this looks is with a very limited amount of water in a dry year, you may have to put some water on early just to keep the crop growing. You don't want it to die, okay? But then you wait and you put most of that water on around tasseling. But some of this, see, this is the red line is tassel emergence. I'm starting sometimes 2 weeks ahead of tassel emergence. In a wetter year with a very limited amount of water, you can have the option of putting all of that water on at tassel emergence, and then an even application, 1 inch a week for 5 weeks, you're out of water. And then you just hope and pray for what happens. As you have more water, you can spread out the distribution of that water around that critical time period. And again, in a dry year, even with 10 inches, you may need some early, but again, we're starting here about 3 weeks ahead of tassel emergence, increasing that amount of water, and then we run out in a wetter year. Again, that can be shifted somewhat, and you probably approximate yields pretty close to full irrigation. With 15 inches of water, it's a no-brainer. That's full irrigation. You're going to follow regular irrigation scheduling procedures. But in a really wet year, you may not need your full 15 inches, and we didn't in this 1 year where we did this. So what kind of yields have we been able to achieve? Realize I'm at 4,000 feet on a sandy soil. This is not a nice Kozad silt loam at North Platte, Nebraska. Yield averages for the last 8 years, if we approximate a non-irrigated, we're maybe at about a 60 bushel yield average. It's probably between 40 and 60. But at our 5-inch level, we're at 128. Roughly 130, 170, 190. One of the questions that will come up and hopefully will generate some discussion on is, as you have limited water, what do you do with plant population on corn? Now generally, on all of the other crops that we have worked at, we have not changed seeding rate. Corn is probably the exception. So normally, if you would say, well, what do these curves look like? Well, in a wet year, most of the time, depending upon what you call a high population over a range of water applications, you know you're always going to be better off planting a higher population. But what happens when you're in a really dry year? Is there a crossover point that you're better off to plant a lower population if you're really low as opposed to higher? Do you pay a penalty for having a higher population in really deficit irrigation situations in a dry year? And then we know when you get to some point, it crosses over and with more water, even in a dry year, you're still going to have better yield. About 4 years ago, I started doing a simple study where I looked at a low and high population. In the 5-inch, those the populations are 16 and 24,000. At the 10-inch level, low is 24,000, the high is 32. And even though I knew it would be a loser, I also did 24 and 32 at my high water level. So here are the yields over 4 years. So when I started this study was 2009. Guess what? I had 3 years of average or above average precip. And I really wondered, boy, I wish I would have started this study back in 2006, and then I would have had 3 years of data in the dry time. Well, luckily, in one way, as a researcher, I got my dry year in 2012. So what do these yields look like? Okay, averaged over high and low years, and I've got more highs than lows, I definitely, with only 5 inches of water in a very dry climate, produced more yield with the 24,000 versus the 16. And that was kind of a surprise to me, especially this year. I did not pay a penalty for the 24,000 in a very dry year. But that's about as far as I would want to push it. When we get to 10 inches of irrigation, though, there really wasn't a major yield advantage of 32,000 versus 24. And in a dry year like this, there definitely was no advantage. So when you look at $320 a bag seed corn, and you look at the differential of, what, 8,000? You're looking at $32 an acre, if my math is right. And 3 bushels less, $32, probably in this mid-range, something around 24, 25 is reasonable. And if you look back through the history, even in the wetter years, on average, you did a little better. That's a little bit of a gray area. So if you're in that area of deficit irrigation where you're probably at 80% of ET, you may want to cut back a little bit. But if you're at full irrigation, no way. You need to retain those high populations. So this is the way the data looks like on a relative yield basis. Yes, in a wet year, you're always better off to plant a higher population. When you have a dry year, we did a little better. My low populations were too low for the 5-inch level. I would have been better off picking 20, but that's where you get into trouble with assumptions. I based that on what we had done at North Platte, and I hadn't done the research, and I just kind of selected one that I thought would work based on how dry it was at Scotts Bluff. The other way that we've been able to use this data over the years is to calculate what I call the relative yields and to define what I call the boundary conditions. So if you have, in a given year, if you've got your yields, you just take your highest yield, which you assume is your maximum, as a divisor, and you calculate a relative yield. So I can take all the years, I can put all the data together, and you have what's called a family of curves. Well, once you do enough years, you throw out everything in the middle, and you have defined the boundary, because 2009 is the good wet year. It's the wettest year that we had. And 2007 and 2012 are no different. This is my driest year. So now I've defined the boundary conditions of here's the best I can get and here's the worst that I can get. In a time, if I only have 10 inches, what's my yield range going to be? If I'm in a wet year, I'm probably going to be with 10 inches in the panhandle. I can probably produce 95 to 97% of maximum yield. But if I'm in a dry year, I'm probably going to be more like 80%. If I've got a 14-inch allocation, it doesn't make any difference. But what you can do is, depending upon your yield level, is you use the percentages and say, okay, well, I'm a darn good corn farmer. I can grow 220. Well, you just take the percentage of the 220 from the curves to give an idea. And this is essentially kind of what is built into the mechanism of Water Optimizer. It's kind of an oversimplification, but this gives you a visual idea of what's going on in Water Optimizer. It's looking at production functions, but you know, this is kind of real life data. When you think about this in the context of water management, because of that information Darrell gave you at the beginning, where he showed you that rainfall distribution across Nebraska with 14 to 15 inches at the Panhandle, 39 inches in southeast Nebraska. What that means in a dry year in the Panhandle for full irrigation, we probably need 14 inches. If I look at my own research from North Platte, most of the time, that's probably on average about 10. And in central Nebraska, that's more like 7. When we go to a wet year, we can probably get by with 11 inches in the Panhandle. We can get by with 7 inches at North Platte. And you should, if you do everything right, be able to get by with about 5 inches in central Nebraska. What is deficit irrigation? It's relative. It's related to where you are, what your beginning soil moisture is, and what that annual rainfall is. The thing we always have to realize is, you know, the scientific data and the facts are out there. The facts don't cease to exist because they are ignored. And that would have been a good moniker, I think, for some of the political debates that we went through the last 6 months before the, before the elections. Some other concepts that you have to keep in mind when you really have deficit irrigation. When you limit irrigation and stress a crop, it does affect ET. You don't get normal ET out of a stressed crop like you do out of a fully irrigated, non-stressed crop. The ET for a given week is only a fraction of the full ET that you get when you go to CropWatch or other sources that provide weekly ET. That's a number from a non-stressed crop. Well, how different is it? Nobody probably grows canola or camelina, but it doesn't matter whether you're growing soybeans or corn or camelina or canola. The same things apply. This is some deficit irrigation work that we did a number of years ago looking at irrigation on these crops. Did a full, complete soil water balance of these things, looking at precipitation, irrigation, soil water, deep runoff, which we didn't have hardly any, and no surface runoff. And lo and behold, for canola, camelina, corn, soybeans, yield ET is a nice linear function. But when you start deficit irrigating, and this is in a dry year, our growing season rainfall was 4.5 inches. You plant canola in the middle of April, you harvest it the end of July. The top curve is ET on a weekly basis. Here's the full irrigation. Here's the next level down, which was about 8 inches. Here's the 4 inches. Here is a true dry land. We cheated a little bit. We put on a 1/2 inch of water. We put on a 1/4 inch 2 times to make sure that we had germination and a stand. But other than that, that's all this got. When you put on less water, you're going to suppress ET. You're also going, if you look at the maturity date, you're also going to decrease the growing life of that plant. And that's going to happen whether you're growing corn, canola, or whatever. So your total evapotranspiration, once you stress it, is going to be less. When you have plenty of rain, it doesn't make any difference. It's all the same. In terms of the amount of water that you use out of the soil, in a dry year, under dry land, you will use a lot of the water that you have in the quote-unquote bank. Under low irrigation, it's pretty similar, but as you provide more and more irrigation, you're going to use less of the stored soil moisture. And at high irrigation, it's definitely less than what you do in a dry year. In a wet year, under no irrigation, again, you're using moisture down to about a 4-foot depth, but under low irrigation, you use less, and under moderate to high, you hardly use any. You're just using the rainfall, and you're probably not getting as good of extraction from the lower levels. Okay, we've done this long enough now. A colleague of mine, Dean Jans, who passed away, has done work on dry beans and sugar beets. I've worked in my rotation, I've got dry beans. So we do have good information for dry beans, canola, camelina, winter wheat, sugar beets, potatoes, cool season grasses, warm season grasses. The crop we don't have good information on is sunflowers, but Joel Sneecloth and the folks in Colorado have some of the best deficit irrigation numbers for sunflowers. We've got the data out there to look at how we time the water and what we look at in terms of getting the most bang for the buck. One of the things that keeps people from doing this is some of the barriers, and a lot of those include old habits and traditions, lack of research. We probably should have some more in some areas. A lot of it is depending upon who owns the land. What's the perception of the landlord, your banker, your neighbors and friends? Is that something that keeps you from making some of the changes that you don't want to look silly doing? Fear of failure, long-term versus short-term, learning curve. Average farmer age, 57, you know. What's the average landlord age? Probably at least 10 years older than that. Solutions, education, demonstration, things that we've done for years, things that they're doing here at the Monsanto Center. Probably need some good mentors, people that have done research dollars. One of the things that I think from a policy standpoint is most important for the NRDs and as people look at single year versus multi-year allocations, if you can develop regulations that reward good management, they should be kept in place. Let's say you're on a 5-year allocation and somebody does a really good job, and at the end of 5 years that person has 10 inches of water left. They should be rewarded for that. The person that ends and at end of year 4 is out of water and complains, he didn't manage well. If we set regulations to reward good management, that will improve things generally for most people. With that said, I'll stop and see if there's any questions. I think the question is, when we do the water balance data and as NRDs set regulations, how do you account for effective rainfall versus total rainfall. Usually in the West, that's not a problem because all rainfall is pretty much effective because an 1.5 inch storm is a big storm. And in a situation here with residue, we probably capture most of that. The further east you come and you get larger storms, if you have a cleaner tilled situation, you do have more surface runoff. Okay. Daryl said that in the crop sim model as a part of Water Optimizer that is simulated. But that is a consideration. You can, it's almost on a site-specific basis. You probably have to pick a number and say, well, we're going to assume 90% or something like that. There's no easy answer, but maybe Daryl has a comment also.
I'll just hit it later.
Okay. The question is, does corn respond in terms of its ET similar to other crops? If you look at, I could show a graph in another presentation of yield versus ET versus corn, soybeans, sunflower. The slope of the line varies by crop. Corn has one of the steepest slopes. If you have adequate water, you get more pounds of dry matter per inch of water for corn than you do for sunflowers or for winter wheat. Soybeans is up close to corn. So you get the slope of the yield ET curve varies by different crops. So in terms of the amount of dry matter that you get per inch of water does vary. The question is ET reduced with limited water? Yes. Anytime you reduce yield, you reduce ET. We're under a linear move. The question is, how did we apply our water here, and did we have better technology than most farmers do? And I'd say probably not. We're just under a linear move sprinkler. We've got drops that are about this high because of the wind, but we set up most of our irrigation. There were a few times where I limited myself where we went up to 2 inches. The last 3 years, I've limited myself to putting on only 1.5 inches of water per week. So 2 3/4 inch irrigations, which depending upon your system capacity is doable with most center pivots. If you've got limited pump capacity, it's a whole different ball game, and maybe that's something Daryl will get into this afternoon. We generally were looking at, never putting on less than 1/2 inch of water because of evaporation losses, somewhere between 1/2 inch to 1.5 inches per week. And on a lot of these, the lower water levels, it was once a week frequency, and at the higher irrigation levels where we were putting on 1.25 to 1.5 inches, it was twice a week frequency. Yeah, we can go back to the question was, do we have all of the weather data in terms of wind speed, relative humidity, temperature for when we did this? And we've got, for an ET, we've got all of this from the Nebraska High Plains Climate Center.